In this section, we'll be talking about division of fractions. Division of any kind of numbers is confusing for most people to understand. Division of fractions is that much more confusing. However, those critical understandings we talked about in multiplication are just as critical in division, and so I want to run through those first to help us make sense of what we're doing when we divide by fractions. So here were the critical understandings we needed for multiplication, and I'm going to go through and modify them one at a time for division, and please pay close attention to see what happens so that our students can understand what they should be expecting when they come up for answers. So if we change multiplying to dividing any starting number by 1 doesn't change the starting number. So 6 divided by 1 is still going to give us 6, and a half divided by 1 is still going to give us a half. So that identity of 1 is critical, and everything's going to be relative to that. So moving to our next one, we said that multiplying any starting number by a number smaller than 1 makes the answer less, but in dividing, that changes. So when I have division, dividing a starting number by a number smaller than 1 makes my answer bigger than my starting value, which is the exact opposite to what we were doing with multiplication. And that makes sense because division is the opposite operation. Let's think about that for a second. If I have one thing and I'm dividing it by a half, which is smaller than 1, my question is how many halves are there in 1? And so I'm going to get the answer of 2. So my answer 2 is going to be greater than what I started with, which is 1. If I have the number 10 and I divide it by a half, I'm asking how many halves are in 10. Well, if it takes 2 tens to make 1, it must take 20 halves to make 10. So if I take 10 divided by a half, I'm going to get the answer of 20. Again, a number that's greater than what I started with, 10. And finally, dividing a starting number by a number bigger than 1 makes my answer less than my starting number. This is the one we're most familiar with. So if I start with a number 10 and I'm dividing by 2, a number greater than 1, 10 divided by 2 is 5, and I expect my answer, 5, to be less than what I started with, because I'm normally dividing by numbers that are bigger than 1. 6 divided by 3 is 2, 20 divided by 10 is 2. I'm dividing by numbers bigger than 1, so I get answers that are less. But today we're going to be talking about dividing by fractions, and so therefore it's going to be reversed. If I'm dividing by smaller pieces, I need to expect to have more of them, and therefore that's a really critical concept. So we're going to do some examples now of just working with dividing by fractions. So here's my starting question. 1 divided by 1. So I start with a 1. I'm dividing by a number equal to 1, 1. And I shouldn't get any change to my answer. And the answer is 1, which is pretty straightforward. So diagramming this, I start off with my number 1. So my number 1 is going to be my inside piece. And my divisor is going to be on the side so that it lines up with our long division way that we write things. So here's my 1, and that's going to be this one here. And I'm dividing by 1. That is this one out here, and my answer is going to be on top. So the same thing with my diagram. I want to have my 1 here, I want to divide by the 1, and I want my answer to be up here at the top. So here's my 1, and I've shaded in one whole box. I want to divide it by 1, so this length here is all 1. That's this one here. And how many of these whole ones do I have in this box? And I can see I have one whole one, so I get the answer of 1. This is a little confusing because it's all the same numbers, but I want to start off with this one to start off with. So division by 1 doesn't change anything. So now in this question, 1 divided by 2, I start off with one whole piece. So here's my one whole, and I want to cut it into 2 wholes. So my 2 whole pieces are found here. There's one whole, and here's another whole. But I want to find out all the way across and all the way down 2 whole sections. As you can see, I only have one whole section. So what I have to do is cut this piece in half and bring it down. So I take my one whole, and I want to find out how many 2 whole pieces I have. So I take it and I move this piece like this. So now I had one whole, one solid piece, one big square, and I want to cut it into 2 whole pieces. So if I want to have lengths of 2 holes, there's the length of one hole, there's the length of the other hole. How far do I have across the top now? And so my answer is 1/2. So 1 divided by 2 is going to be a width, of 1/2. So here I have a question. I'm starting with my starting number. I'm dividing it by a number bigger than 1, and I expect to get an answer smaller than what I started with. And I do. I get 1/2. I'm also showing this 1 divided by 2 over 1, because 2 is the same thing as 2 over 1, and my answer is 1/2. I would like you to do a few examples of this. I'll do a couple, and I'm going to leave them here so that see if the students pick up a pattern. So I'm leaving my question down, my previous question down here, moving on to this question. 1 divided by 1/3. I have my starting number, and I'm dividing by a number smaller than 1. So I'm dividing by smaller pieces, so I should expect to have more of them. So I've started off with my 1 whole, which is what I start off with. I fill in the inside piece with what I start my first number, and I want to find out how many thirds there are, how many thirds are in 1. So here's my thirds, and so I want to go horizontally now. So I've resized it a little bit. My question is 1 divided by 1/3. So in other words, how many of these blue 1/3 strips can I make out of 1 whole block of yellow? How many thirds are in 1 whole block? So I can see that I can make 1/3. But then I've also got another one here that I can make, and I could also make another one here I can make. So I could take these and say that I can make 3 of these. So since I can make 3 of these, I can move them up here, because remember our answer is how far across the top is it? So I move them across the top, and now I've got an answer of, I've got 1 whole, 2 holes, and 3 holes. So my answer to this question would be 3. How many thirds can I make out of the big hunk of yellow? I can make 3 holes. I can make 3 thirds, pardon me. 3 whole thirds. So my answer across the top here is 3. And there's our work there. How many thirds are in 1 hole? There are 3 thirds in 1 hole, and that's how I might go about showing that. So in this question I start with a 1, I divide it by 2/3. I'm dividing by a number smaller than 1, so I expect to get an answer bigger than what I start with, 1. So how many 2/3 can I make out of 1 whole? So here it is in my diagram. There's my 1 whole. My blue piece is a 2/3, 1, 2, 3, and I've shaded in 2 sections of it. And the question is, how many blue 2/3 can I make out of a yellow? Well, I've got enough to make 1 whole blue, and I've got some left over. What do I do with the leftover piece? If I take my leftover piece and I move it up here like I did before, I now have 1, 2 holes, but I don't have 2 holes. I want a piece that's this big. It goes this far, and it needs to go 2/3 down. This one only goes 1/3 down. So what I can do is I can cut this in half and rearrange it. Now that I've cut it in half, I can take this piece and slide it down onto this piece. And so now I've got full 2/3 pieces. So my question is, how far is it from here to here then? Well, I've got 1 hole, and each of these pieces are a half of this one. So therefore, I've got 1 and a half. So my answer to this question is 1 and 1/2. It's important to recognize that it's 1 and a half what? It's 1 and a half 2/3, because we're saying how many 2/3 are in 1. We've got 1 2/3 and half of a 2/3. So it's 1 and a half 2/3. If I change this into an improper fraction, I will get 3 over 2. And now is a good time that we might have enough examples to show, or you could do more, to see if the students notice the pattern. If they don't see the pattern, do a few more, and then maybe point out something to them. 1 divided by 2 over 1, and the answer is 1 over 2. 1 divided by 1 over 3, and the answer is 3 over 1. 1 divided by 2 over 3, and the answer is 3 over 2. Some students will notice that if I do my division question, I end up getting the reciprocal, or this upside down version. And the definition of reciprocal is the number you have to multiply by this to get to a 1. So the reciprocal is the flipped version of them, and these diagrams show that reciprocal nature. I could also change these questions to multiplication questions and see what happens. And we can point out that if we take 1 divided by 2/3, we get an answer of 1 and a half, or 3 over 2. 1 times 3 over 2 gives me the same answer. So I change my division to a multiplication and I multiply by the reciprocal. 1 divided by 1/3 becomes 1 times 3 over 1. I get the same answer. 1 divided by 2 over 1 is the same thing as 1 times 1 over 2, and I get the same answer. So we can show the students that this multiplying by the reciprocal works. And so that's one technique for using division of fractions. Now I wouldn't show that right away, but it's something that we can show the students later on. And you can show it visually where that multiplying by the reciprocal works and why it works that way. So I'm going to stop here. We've covered dividing of proper fraction. If I divide by a number smaller than 1, I get an answer that's bigger than what I started with. That makes sense. I need more pieces. If I divide by 1, I get the same size piece. And if I divide by something that's bigger than 1, I'm going to get a smaller size piece. And I've shown that with my diagrams. And I've also shown how that multiplying by the reciprocal concept can be created and discovered by students. And so that when we go to talk about that later on as one of the quote shortcuts of doing division of fractions, we can see where it comes from.